テスト、テスト、テスト、テスト、ストリーミングオンリー、テスト、テスト、あれ何も言ってないですよね。ね。これは来てる。ほんなら、これはマイナス1やから、オッケーオッケー。
Salve, buonasera, mi sente?
Salve, ci sente? Io e lei non la sento. Ok, perfetto, ora sì, 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 perfetto. Ok. Guarda, stiamo per iniziare, quindi tra poco vedrà pure la sala. Ok, grazie mille. Arrivederci.
Hello, everyone. Can you hear me? Okay, now, yes. Good afternoon to everyone. I'm Matteo Serra, science journalist and communication officer for the National Institute for the Nuclear Physics, INFN, and welcome to the panel Sardinia, Territory of Science, organized by Sardinia Region with the collaboration of INFN and also the National Institute of Astrophysics, INAF, with the goal to highlight the scientific role of Sardinia, in particular in the field of the big research infrastructures. This event will be divided in two parts. The first part will be dedicated to the presentation of the Einstein Telescope project, a future gravitational wave observatory that will be built in Europe in the next years. That Sardinia and Italy are candidate to host, in particular in the heart of the island, in an area around a former mine, the mine of Sosenatos. And in this first part, we'll also explore another important theme, the important synergies between Japan, Italy, and Sardinia, in particular in research in the field of gravitational waves. In the second part, we'll focus more deeply on the activities that are currently ongoing in Sardinia, in particular in the candidate site for Einstein Telescope, but will be also the occasion to present you two other very important major scientific infrastructures operative now in Sardinia, the project ARIA in the field of the search for dark matter, and the Sardinia Radio Telescope, one of the biggest radio telescopes in Europe managed by the National Institute for Astrophysics. Okay, but before to start, we have, of course, the institutional greetings, and we start with Mario Vattani, General Commissioner for Italy at Expo 2025.
Thank you. Thank you very much, and welcome to the Italy Pavilion at Osaka 2025. Now, we're very glad to welcome today Deputy President of the Sardinia region, Honorable Giuseppe Meloni. Together with the Vice President, we toured a little bit the pavilion. I hope you will have a chance to visit yourself. We're very honored to have such a large number of Italian regions who have chosen to join us in this project. Sardinia will be hosted from last Sunday to Saturday. Already I have to congratulate the Sardinia delegation for the quality of the exhibits that go from, I mean, I would say that they totally took the same line that the Italy Pavilion chose to talk about Italy, to talk about its territories, and to talk about its culture, of course, but also, and we see it today, to talk about its high technology, its very high quality products, its very high quality academic network, and of course also research and the future, which is exactly what Expo is about. So we chose to describe a nation, in the case of Italy, which doesn't have to concentrate on time. There's no Italy of the past or Italy or contemporary Italy or Italy in the future. What you can see in this pavilion and what you can see in the wonderful exhibits by Sardinia during this week is an Italy which has no time. It's an Italy which goes from the past to the future and is part of the same exercise of, I would say, ingenuity. I'm also very happy to welcome the delegation from INFN, and I want to take this opportunity to thank the president of INFN, Antonio Zoccoli, because INFN has been a partner for us since the very beginning of our plan to participate in Expo. I know that there will be maybe from Italy we will hear an intervention by Director General Michele Mazzola, which is from the Ministry of University and Research, which is also our partner in Expo. And I don't want to keep you any longer, but please consider that a region like Sardinia, which is which has some characteristics that are really unique as a region compared to the rest of Italy, has chosen to also present itself by its craftsmanship. So please also visit the beautiful arts and crafts that you will find at the entrance of the pavilion. We have artisans of extremely high quality. Some of them, I'm just thinking, for example, of Mrs. Uru, which of course comes, which through textiles is now about to collaborate with one of the most important companies in Japan, Toyota. So you can see that it goes from really from local to global in the real sense of the word. So welcome once again, Sardinia, and welcome to you all to the Italy Pavilion. Thank you.
Thank you, Commissioner. Thank you. And now I remind you that the Italian candidacy for Einstein Telescope is supported by three institutions, Sardinia Region, INFN, and the Ministry of University and Research. So now we have the institutional greetings by the representative of these three institutions. We start with Giuseppe Meloni, Vice President of Sardinia Region, and also local Minister for Planning, Budget, Credit, and Territorial Governance. Please.
Buon pomeriggio a tutte e a tutti, con grande piacere che partecipo a questo evento così importante organizzato dall'Istituto Nazionale di Fisica Nucleare, che ringrazio per essere presenti oggi, per aver organizzato l'evento e per la collaborazione che negli anni è in corso ed è sempre più forte con la Regione Sardegna. E ringrazio il Centro Regionale di Programmazione, che guido anche come assessore del bilancio e programmazione della Regione Sardegna, che svolge un ruolo fondamentale e nevralgico per il progetto che oggi verrà illustrato. Siamo qui per evidenziare un momento cruciale per la nostra regione e per la comunità scientifica europea. Ringrazio di cuore l'ambasciatore Mario Vattani per aver presentato la Regione Sardegna nel migliore dei modi, quindi non è necessario che lo faccia anche io, perché è stato ambasciatore anche della Sardegna presso Osaka, oggi presso questo momento di confronto, perché ha colto in pieno quella che è l'attenzione che la Regione ha riservato a questo importante momento di Osaka. Porto i saluti anche della Presidente Alessandra Todde, che mi ha incaricato esplicitamente di farlo e di ringraziare l'ambasciatore, ringraziare appunto nella sua funzione di commissario generale per l'Expo e tutti gli organizzatori anche di questo evento, oltre che della settimana della Sardegna. La Sardegna, come è stato detto, si candida ad ospitare il futuro laboratorio europeo dedicato alle onde gravitazionali. Su questo il governo italiano ha investito per il momento quasi 1 miliardo di euro e la Regione Sardegna quasi 500 milioni di euro, a dimostrazione dell'importanza che riveste per l'Italia tutta un evento di questo tipo. Un progetto ambizioso e fondamentale per l'avanzamento della ricerca scientifica. Non è solo questo un riconoscimento delle nostre, ritengo, consolidate competenze scientifiche. La Sardegna ha dimostrato in passato di essere terra di scienza, all'avanguardia dal punto di vista della ricerca scientifica e tecnologica, ma anche un'opportunità per mettere a frutto le straordinarie appunto, capacità di questo territorio. Con il sito di Sosenatos la Sardegna offre caratteristiche uniche che la rendono ideale per questo progetto, come è stato anche detto. Inoltre, come è stato annunciato, siamo orgogliosi di presentare le infrastrutture ARIA e Sardegna Radio Telescope. ARIA con la sua colonna criogenica destinata alla produzione di gas isotopicamente puri e Sardegna Radio Telescope, uno dei più grandi avanzati d'Europa. Sono esempi entrambi tangibili della nostra eccellenza scientifica e della capacità di realizzare infrastrutture di livello internazionale. Desidero ora sottolineare l'importanza della ricerca scientifica e dell'investimento tecnologico non solo per il progresso della conoscenza ma anche per la crescita economica della nostra isola, ed è per questo, anche per questo che investiamo tanto in questo settore. Investire in tecnologia e innovazione scientifica significa creare opportunità, attrarre talenti e stimolare nuovi settori economici. La ricerca non è solo un motore di sviluppo, ma rappresenta anche un volano per l'occupazione e il benessere delle nostre comunità. La Sardegna riteniamo abbia tutte le potenzialità per diventare un punto di riferimento nel panorama scientifico internazionale. Questo è un obiettivo che possiamo raggiungere insieme. Ringrazio ancora una volta il commissario generale Mario Vattani e tutti coloro che hanno reso possibile questo evento e colgo l'occasione per sottolineare l'importanza della collaborazione tra istituzioni e comunità scientifica, che è fondamentale per il successo di iniziative come queste. Vi auguro una giornata ricca di stimoli e di scoperte. Grazie a tutti, buona giornata.
Grazie. Thank you so much. And now the greetings from INFN with Alessandro Cardini, Director of the INFN Cagliari section and member of the INFN Board of Directors.
So, ladies and gentlemen, good afternoon. On behalf of INFN, the Italian Nuclear Physics Institute, I welcome you to this event called Territory of Science. This event is organized by Regione Sardegna, INFN, and INAF, the Nuclear Astrophysics Institute of Italy. And the intent of this event is to further consolidate the international cooperation which already exists between our country, Japan, and Italy. From this point of view, I would like to remind you that 1 year ago, on the 27th of June, an agreement was signed between Italy and Japan, between our Minister of Research, Anna Maria Bernini, and the previous Ministry of Science of Japan, Masahito Moriyama, to develop together new technologies, in particular for Einstein telescope, in a context of a bilateral plan of cooperative action for improving the research. INFN has already a long-standing tradition in collaborating with the Institute of Cosmic Ray Research at the University of Tokyo. We work together on neutrino physics and also new physics. And with this further cooperation that we are putting together now, we want now to develop, to work together with CAGRA, the gravitational wave observatory that exists in Japan, to further improve the cryogenic technologies and to realize an exchange of ideas, technologies between our two countries to create Einstein telescope, to work together with CAGRA and improve its sensitivity. Sardinia is one of the two biggest Italian islands, and as we will show you today, it's a territory for new opportunities and also for scientific opportunity. And this is really what we want to show you today. I want to acknowledge the continued support of Regione Sardegna, not only for the organization of this event, but also for the fundings that they invest in our research that allow us to further do progress in this direction. So I hope that you will enjoy our presentation on how we think this Sardinia is a territory of science. Thank you very much.
Thank you, Alessandro Cardini. We'll meet you again later in the second part of the event. And now we close the institutional greetings with a live connection from Italy with Michele Mazzola, representing the Italian Ministry of University and Research. Dr. Mazzola, can you hear me?
Yes, of course.
Perfect. Go, please.
Good afternoon, everyone. Good morning from Italy. Authorities, researchers, ladies and gentlemen, I'm glad that you have the opportunity to speak moreover online and not in person. I'm sorry for that. At the opening of this event on behalf of the Ministry of University and the Research. So let me start with an image related to what the speaker before me said, just to relax the audience. Imagine being in Sardinia. It's very simple for the Sardinian people present in the hall, but it can also be simple for the other. Picture is white beaches, crystal clear sea, and the brilliant light that outlines the national land. A land known not only for its stunning landscape, but also for its millennia-old history, rich culture, living tradition, and a cuisine that speaks of identity, as you know. Today, we had another reason to know and appreciate Sardinia. We present Sardinia as an emerging hub of international scientific research. And if we've long associated the island with the rhythm of the sea and the sound of its waves, today we focus on a very different kind of wave, an invisible, silent wave that travels across the universe, carrying the echoes of cataclysmic cosmic events. A gravitational wave generated by collision of black holes or neutron stars, as we discuss on ahead. And very soon we may be able to observe those waves right in Sardinia. Let me thank the Autonomous Region of Sardinia, the Italian National Institute for Nuclear Physics, and the National Institute for Astrophysics for organizing this event with an evocative title, A Territory of Science. We are here to share Italy's commitment to hosting the Einstein Telescope, the next generation European Observatory for Gravitational Wave Detection, and to propose Sardinia as its ideal host territory. Sardinia is not just a possible location, but it is, in many respects, the most suitable one. Its geological and environmental conditions, low seismicity, minimal human interference, and underground stabilities make it an optional setting for this highly sensitive and complex scientific infrastructure. This vision is already grounded in excellence. Sardinia is host to ARIA, a project for the isotopic separation of argon, and the Sardinia Radio Telescope, as you said before, an internationally recognized facility for radio astronomy directed by Federica Govoni, who will speak with us later. These infrastructures not only reflect Sardinia's scientific maturity, but also provide a robust and coherent foundation for a broader research ecosystem. It is also important to highlight that the Italian government, the regional government, and the Ministry of University and Research in particular at the moment invest in this direction with a sustainable amount of funding. For instance, thanks to National Recovery and Resilience Plans, the Ministry has allocated a target investment of 19 million euros in Sardinia to strengthen its research infrastructures in general, not only ARIA and Sardinia Radio Telescope. We consider that this is not just an investment in technologies. It is an investment in Sardinia's role as a Mediterranean and a global scientific hub, capable of attracting talent, building international partnership, and nurturing the next generation of researchers. The decision to propose Sardinia as the site of the Iceland Telecos stems from a clear and strategic vision to make the most of the island's unique characteristics and maximize the return of a long-term scientific and economic commitment at both national, European, and global levels. Today, we will hear from key figures linked to this project. Let me thank all the speakers today participants in this event, but more generally for their work, the passion and the heart, let me say, that they put into their jobs, particularly in the pathway to achieve the common goal of hosting Iceland Telescope in Sardinia. Let me conclude, Sardinia is not just a strong candidate, it is, in our view, the most efficient and effective choice, scientifically, environmentally optimal, and already embedded in a thriving research landscape. From the waves to sea to the waves to space-time, Sardinia is ready to host the future of science with Iceland Telescope. Thank you for your attention and good job for all.
Thank you so much. Thank you so much, Michele Mazzola. And okay, now we are ready to start. I kindly call here on stage the speakers of the first part of our event, Michele Punturo, Monique Bossi, Alberto Masoni, and Takeyuki Tomaru. Please. Okay, in this first part, as I anticipated, we'll talk, this part will be dedicated mainly to the presentation of the Einstein Telescope project and also the collaboration with Japan and also the Italian candidacy, but we start with a general presentation of Einstein Telescope. So we have Michele Punturo, the coordinator of the International Scientific Collaboration Einstein Telescope.
Okay, I hope, okay, perfect. How to change slide, I will tell...
I think there is something, okay.
Nothing.
It's coming.
It's coming.
It's coming.
Perfect. Okay, I suppose the green button is the right one. Okay, so thanks for inviting me. I'm the international coordinator of Einstein Telescope. You will see what it means to be the international coordinator of Einstein Telescope. But Einstein Telescope, what is? Einstein Telescope is a future gravitational wave telescope, better observatory, that wants to listen this particular signal predicted by Albert Einstein, the gravitational waves. And what is a gravitational wave detector? Are these beasts that you see here, these large telescopes? In reality are the big microphones. Big means the Virgo one in Italy is 3 kilometers by 3 kilometers. In US, they are American, so it's 4 kilometers by 4 kilometers. And now we have also in Japan, Kagra, that is implementing new technologies that we are interested in. And the principle of this kind of machines, it's quite complex. Is a complex machine using optics, mechanics, electronics, the cutting edge of technology. So this is also the interesting part. It's our large research infrastructure. And what we want to do with this large research infrastructure? To detect gravitational waves. Gravitational waves are a prediction of general relativity. General relativity is the best theory of gravitation that has been realized, means produced by Albert Einstein 1 century ago. And after 1 century, we have been able to detect with that beautiful machines the gravitational waves. In 2015 and 2017, we discovered the gravitational waves emitted by black holes in 2015 and by neutron star in 2017. And okay, we discovered that Einstein was right. These bodies are emitting gravitational waves. But in reality, what happened? In reality, it happened that we opened a new era for gravitational wave astronomy, a new way to observe the universe, using different information, the so-called multi-messenger astronomy, coming from these remote bodies. For the first time, we have been able to listen the black holes. The only signals coming from black holes are gravitational waves. It was the first time. We have been able to compare in general relativity with respect to other theories, and we need it because we are not able to understand our universe, and we need to study alternative theories. And we measured the expansion of universe. We studied the neutron star nuclear physics, and finally studied the population of black holes. All that with this new window open on the universe. So this is a change of game, a game changer for the observation of the universe. And a game changer that in Italy we had many centuries ago with Galileo that started to observe with the cannocchiale, the small telescope, first the moon, but then Jupiter, and discovered that our concept of the universe was wrong. There are not concentric spheres, but we are not at the center of the universe. And now we are using a huge telescope to observe the entire universe. Now, with the gravitational wave detector, we are in the same situation. We opened the window with LIGO, Virgo, and now CAGRA, and we wanted to observe the entire universe with the Einstein telescope. So we are in a new revolution that has been just started. And it is a long path. Einstein telescope, this body that you see under this picture, is a 10 kilometer, maybe 15 kilometer by 15 kilometer interferometer, underground cryogenics that is quite close to the CAGRA concept, and using very new technologies. And the path to arrive just to the idea of Einstein telescope now is already quite long, more than 20 years of development to say, okay, it is possible, we want to do it, and maybe in Sardinia. And in fact, Italy lead a team of 5 governments presenting in this ESFRI committee, is the International Committee for Future Research Infrastructure, is a committee of the European Council. And Italy lead a team of 5 countries, so Italy, Netherlands, Belgium, Spain, and Poland, for proposing this new facility. And now we are a complex enterprise. A complex enterprise organized with a complex structure that you see here. I don't want to enter in this complex infrastructure, but I want to tell you that now the countries that are supporting Einstein telescope are 10 in Europe. So it's a really pan-European enterprise. But if you go beyond, we see that the scientists interested to Einstein telescope are the scientists of all the globe. And we have, of course, the focus in Europe, but we have colleagues from US, South of America, Asia, in particular Japan, are quite interested, Australia. So there is a global interest in this new facility. And Italy plays a dominant role, at least in terms of ideas and the people, of scientists. We are the largest component of IT. And what are the message, what are the questions? Science answers questions and create new questions. So we never answered all the questions, we create new questions. But the question that we are trying to answer is the fact that if general relativity is the theory that explains the universe, are the compact bodies that we see really the black holes predicted by Albert Einstein? We know that we understand the 5% of the universe. All the rest of the universe is not understood by us. We believe that there is a matter that is called dark matter that is one of the target of the ARIA facility in Sardinia. So we wanted to understand what is that. What is the nuclear physics inside the star? What we can learn observing the star with the Sardinia radio telescope, with Einstein telescope, with different kind of telescopes. And what is the dark energy? Another big question mark in the universe. And the black holes that we know, the supermassive black holes that are weighing millions, billions of solar masses. What are these objects inside in our galaxies? And to do that, why all the governments are interested? Our science is beautiful, but our governments are interested because to do that, we need to develop a huge amount of technology. So challenging engineering, cryogenics, new optics, new lasers, new mechanics, and optoelectronics and quantum optics. And this is both for all the facilities of Einstein telescope. And can conclude saying, of course, Sardinia is candidate to host ET. There are competitors in Europe, in the north of Europe, in Netherlands, in Germany, and there are many parameters that we are investigating. And now I'm removing my hat of international coordinator, put my hat of national coordinator, and say, okay, but Sardinia has the best quality of the site, but cancel this in front of my international colleagues. Thanks to everybody.
Thank you so much, Michele. And now, okay, about the Italian candidacy. In Italy, there is a project, the ETIC project, funded by the National Recovery and Resilience Plan. And we have now the presentation of Monique Bossi, which is the infrastructure manager of ETIC project.
Thank you, Matteo. Thank you, Matteo. Thank you, everybody, distinguished guests. I'm happy and honored to be here. Thank you to the Sardinia region, to the Italian government, and of course to all of you that are interested in our presentations today. So I will try to lead you briefly and to tell you about the meaning and the structure that is needed to give support to the candidacy. So I am not a scientist. I just try to give my contribution to this adventure, which is, of course, not only a scientific, a visionary endeavor that has been described by Michele Punturo just a few seconds ago, but is, of course, also an institutional, let's say, political, financial endeavor that needs some specific structure and a well-established path. Okay, so as said, we are talking about a candidacy because there are, of course, competitors. And we have two competitors, which is a strange case because we are at the same time cooperating in the international collaboration, but we are also competing to host and to bring the telescope home. So we know that there is a candidacy in Germany, in one of the regions of Germany, better to say, at the border between the Netherlands, Belgium, and Germany. And of course, we have the Sardinian candidacy, that is the national candidacy of Italy. So what it means to be a sound candidate? It means that you need political support. And we are very glad and very honored to have receiving the support from our governments throughout different say mandates. So here you see at least two prime ministers, two presidents of Sardinia region, and other ministers or representative of local authorities that, never mind the, let's say, political colors that they belong to, they have supported the candidacy, meaning that is, of course, super political, and that is really a national, profound commitment, this candidacy. Okay. We have seen that, of course, you need a structure. The structure that has been put in place in Italy is quite complex, and it groups hundreds of people, I must say, representing different profiles. You have, of course, scientists, you have engineers, you have administrators, communicators, managers, because all these profiles are needed because, as I said, the action is taking place at different levels, and you need to be present at all levels and in all different meetings and moments. So in Italy, we have these structures that is called TETI, that stands for Team for ET in Italy, that try to group all the competencies, the experience, and the knowledge that is needed to bring flesh to the candidacy. In particular, we have the scientific part, the engineering part, the technological part. So we are grouping together to produce and to realize a sound candidacy. We need, of course, support, and support is usually represented by projects. So we have been able to count on some concrete support from different projects, and these projects have allowed us to tackle the different challenges that are represented by such an endeavor. So we have the technical and economic pre-feasibility study that is already taking place and that will be concluded at the end of this year, that is financed by the National Recovery Plan through the INFN. And this is, of course, one of the biggest part of the study that we are producing. We have then other projects that are funded by the National Recovery Plan that are tackling different aspects. So the first one that is called ETIC is, let's say, the big project supporting the candidacy, and it's worth 50 million euros that are more or less $70 million. And then we have two other projects that are supporting specific parts. The Terabit project that is supporting the part devoted to the connectivity and the resources linked to the high-performing computers. And then we have the MIT project that is coordinated by the Institute of Volcanology and Geophysics that is exploring more in depth the activities linked to the underground laboratory in Sardinia. And as we said, we need to develop a huge amount of technologies, and to do this, of course, we have received funds to upgrade and also build new facilities in Italy that will develop and provide the Einstein telescope with the needed technologies, enabling technologies. Here you see a list, I won't go into the detail of the list, but you see how complex and how diverse is the activities that we are following. And of course, next to the technologies, you need people. So we have hired more than 50 people specifically working on the candidacy and to bring everything and to group everything together. Of course, as I said, next to the national commitment, we are very glad to count on not only on the commitment and support, but also on the daily collaboration, I must say, is really an operational work that we are conducting together with the delegates of the regional government of Sardinia. Sardinia region has put in place as well a structure that is for us fundamental, because we are able to work together with different offices, and we are able to interface with different levels of activities. Of course, you have the institutional aspects that are, of course, needed, and then you have the promoting committee, because if you want to install such a huge experiment and infrastructure in a territory, you need to talk with local people, because you're going to work in their land. So you need to talk with them to explain what this is all about. And of course, as said, the Sardinia region has committed, on top of the national funding, a huge amount of money that you can see here that is devoted both to the communication, to the preparation of the candidacy, but also to the rehabilitation of the area. And I just want to highlight an important moment that is, to me, at least representative of the success of this collaboration between national and regional authorities, that is represented by the organization of the G7 Conference on Large Research Infrastructure that took place last October in Sardinia, near the candidate site, which is not really, so to say, like Rome, easy to reach, but it was a huge success to bring there the delegation and the representatives of many countries in the world. Again, as I said, Sardinia region is providing huge support to this adventure, and in particular, just to be very concrete and very operative, we are now starting the building of a new research center in the candidate area, so near the Sosenatos mines, that is called the Sardinia Underground Laboratory, the so-called SUNLAB. And here, as I said, we are really beginning the work like next month, I think, if I'm not mistaken. And here you can see again the cooperation between the Sardinia region and, in this case, the three main national research centers, so INFN, the Institute of Astrophysics, and the Institute for Geophysics, that together are funding the construction of this new research center that will host many scientific experiments. So here again, to be really the meaning of Sardinia as a territory of science. So this is more or less what I wanted to present you today. Okay, here you can see some of the conclusions and some of the messages that I wanted to deliver today. What is most important to me is to underline again that this is a national candidacy that can be bring forward thanks to the regional support. And this is really a joint endeavor that hopefully will bring us to the success of the candidacy. Thank you very much.
Thank you, Monique. And now, following this point related to the Italian candidacy and also about the impacts, the possible impacts of Einstein Telescope on the territory, we have the presentation of Alberto Masoni, coordinator of the ETIC project in Sardinia, about the socio-economic impact of Einstein Telescope.
Thank you, Matteo. Vice President Meloni, distinguished guests and colleagues. I will consider another aspect we heard from Professor Punturo, the scientific ideas and challenges related to Einstein Telescope, but it is not only science. As all larger research infrastructures, there are other parts. There is also the socio-economic impact of these infrastructures. Okay, a few acknowledgements, in particular this presentation. I'm indebted to Luigi Guiso, who is the advisor of the committee nominated by the Minister of Research for Einstein Telescope in Italy, Raffaele Marras, who is advisor for Einstein Telescope to the President of Sardinia Regional Government, then Marco Pallavicini, Vice President of INFN, and last but not least, there is the Ambrosetti House, they organized a very important Chernobyl meeting, or World Forum of Economics, and they prepared a very interesting report on the socio-economical impact of large research infrastructures. Because the point is that it's not only science. People do not expect from research just to push forward the advancement, the frontier of knowledge, but to have benefits for society, to have economic benefits. And actually the Ambrosetti study give also numbers. The total, in the last 50 years, the total economic value of research infrastructures is over 500 billion euros, or US dollar. It's more or less the same. So this is what I would like to quote: the usefulness of useless knowledge. That means that our mission is fundamental research, but from fundamental research, we can have innovation and development. And this quote comes from a guy named Abraham Flexner, who was the guy who called to the Institute of Advanced Study Albert Einstein. As in Professor Michele Punturo presentation, of course, all this research is deeply related to the theory of Einstein of general relativity. But I believe that many people here may ask what they use. So why do we need such a complicated theory of mass that shapes space and time? What is this effect of time? Maybe it's just a science fiction movie. No, it's reality, because just to give what I think the most striking example, we have demonstration and practical awareness of Einstein theory that the mass of Earth affects time because a clock on Earth's surface runs differently from a clock in a satellite. GPS, which is the base now of all navigation, land, sea, air, could not work. Your Google Maps or whatever you are using would fail by 30 kilometers if we wouldn't know the theory of general relativity, because the times runs in a different way. So this, I think it's just one example that useless knowledge can be useful. But as anticipated, large research infrastructures has a major role in this development. There are 3 major infrastructures in Japan. One of them, KAGRA, is dedicated to gravitational waves. As already mentioned, the Einstein telescope is the most relevant project approved by the European Strategy Forum for the next 10 years. And we have a candidacy from Italy in Sardinia. Again, entering the socio-economic impact of research infrastructure and in relationship with Italian candidacy, there was this G7 event dedicated to the socio-economic impact of large research infrastructure. This was an initiative directly promoted by Italian Minister of University and Research, Anna Maria Bernini, and it was a critical decision to host this in Sardinia and near the site candidate to host Einstein telescope. And let me make also a bridge. We spoke of cultural heritage. We have here in the Italian pavilion an example of cultural heritage of Sardinia. Let me remind another point. It was underlined that also by Vice President Meloni, that we have an exceptional site in Sardinia because of silence. So let me quote one Grazia Deledda, Nobel Prize from Literature, who was born in Nuoro, just 30 kilometers away, the ideal site. The greatest things are said in silence. This is, and so, I mean, this was really a big occasion for saying really great things. So concerning investments, you already saw some figures. Let me put just in detail. We are now, this was from the G7 event, but in the space of more or less little more than 6 months, this investment has already increased. We are at about at the level of 170 million. It concerns not only research infrastructures, but also general infrastructures as an example of the collateral effect for the territory. And as already mentioned, we have an overall commitment of about 1.3 billion from the regional government of Sardinia and the Italian government. And concerning evaluating the effects, as I said, there was a specific presentation at the G7 in Sardinia from Luigi Guiso. We distinguish from the construction phase and the operational phase. The construction phase, of course, has a big, let's say, in a relatively short period, 10 years, a big impact. We are at the level of 2 billion euros, which become 6 billion with the collateral impact calculated by the economists on the base of experience of other research infrastructures. There will be over 3,000 people working for about 10 years on that. But also the operation will represent a significant amount because you should consider, well, CERN, which is the major European and maybe worldwide infrastructure for fundamental research, is operating since more than 70 years. So you have to project the numbers, the yearly number of a very long period. And the benefits are not only for the scientific community or for scholars, but there are benefits for enterprises, of course, because you saw the figures, the numbers of investments involved, and to the society overall. There is something I would like to quote. I made a presentation with Luigi Guiso several years ago, and it was in Bitti. You heard that here there are the tenores, which represent a world heritage. And a former teacher told me, we had a high school, but because of lower population, there is not anymore. We expect to have again a high school here because of this laboratory. This is just an example. There are effects on productivity growth, but now I'd like to conclude. As I said in conclusion, we have a big investment today already done at the level of 170 million. We have a strong commitment at the level of 1.3 billion to host this infrastructure in Sardinia, both from Sardinian government and Italian government. And we are speaking of something that has the size, considering the overall impact of 6 billion euro. Thank you very much for your attention. Arigato gozaimasu. I hope I spelled correctly. Thank you.
Thank you, Alberto. Thank you. And now, okay, we are in Japan, in Osaka, and the collaboration between Italy and Japan is very strong since a lot of years, in particular in the field of gravitational waves, but not only. And we have the pleasure to have here Takayuki Tomaru, the director of the Gravitational Wave Project Office here in Japan.
Okay, thank you for inviting me to this event. So my talk is mainly focused on emphasizing the Italy-Japan collaboration towards the Einstein telescope here. But before going to the main topics, I wish to give a little bit supplementary explanation about the gravitational wave astronomy, because I found that many non-scientist audience are here. So as Michaela explained about the importance of the gravitational wave astronomy, now the gravitational wave astronomy is one of the most important field in the astronomy. Gravitational wave is a very new and strong tool to look for to search the universes, which are predicted by Albert Einstein 100 years ago. So it is the reason why we could not catch the gravitational wave for 100 years. The size of the gravitational wave is too tiny. So many people, scientists sometimes say that the size of the gravitational wave is corresponding to the hydrogen size, hydrogen atom size between the Earth and the Sun. So in practically saying, the size of the gravitational wave is much smaller now. So anyways, now we successfully catch the gravitational wave signals from the universe. And this is a very strong tool to investigate, for example, the black holes. So we cannot never see the black holes by optical telescope. But by using gravitational wave telescope, we can see black hole directories. This is one of the important science. And the gravitational wave detectors, so now the Virgo in European project and LIGO US project, both two telescopes leading the gravitational wave astronomy. On the other hand, in Japan, so we started the construction of the gravitational wave telescope from 2010, about 20 years later than the construction of the LIGO and the Virgos. But on the other hand, for just 20 years, the technology largely developed. So Kagura introducing the many up-to-date technologies. For example, the underground site of telescope and cryogenics mirrors. These are very effective to reduce the noises. That is very effective to increase the sensitivities. So these two features, underground site and cryogenics mirror technology, these two features will be introduced in the future third generation gravitational wave telescope, Einstein telescope. So the Italy-Japan collaboration towards Einstein telescope is pretty important because it is possible to reflect our Kagura's experience to future Einstein telescope. So this is just showing the history of the Italy-Japan collaborations. So this is a collaboration program in Italy. They have the many collaboration programs from 2012. So for example, the first program was the ERITES program. This is a kind of the exchange of the scientists programs. Based on this ERITES programs, we organized 5 times general meetings in Japan. So last one was 2017. And after that, Italian people obtained the new windows on the universe and technological advancements from trilateral EU-US-Japan collaboration from 2017 to 2023. And after that, Phobos program and also gravity program. This is from 2026 to 2030. So for long term, we are keeping the good collaboration between Italy and Japan. In Japan side, we also obtain the counterparts people exchange, scientist exchange programs. We obtained the two core program, which are funded by the JSPS, and from 2013 to 2023. Unfortunately, 2 years ago, this program has been expired. But we are considering to apply the new collaboration project in Japan too. So, and also now we have the 2 LOI, letter of intent and memorandum of understandings related to the Einstein telescope. First one is the Einstein telescope collaboration and Kagura collaborations one, which started from the 2019. And also now the Perugia University starts the construction of the new research facilities, CHAOS. So to promote the CHAOS project, the Perugia University, our NAOJ, and ICR University of Tokyo have the memorandum of understanding from 2023. Okay, so next I wish to show the many pictures to show about our good collaborations. So in fact, to realize the Kagura project, we learned many things from the Virgo people. For example, the mirror suspension system design was learned from the Virgo suspension systems. And this is the collaboration work. So this is Professor Helios, and maybe this is me. So we joined the installation work of the Virgo mirrors in Italy, and also we doing the collaboration measurement, collaboration research for the fundamental research in Roma University in past. And after that, the many Italian people came to the Japan to promote the Kagura project. For example, the up to one, these white guys, they are not crazy. So they are just working in the very clean environment. So they are contributing to the realization of the cryogenics mirror systems. The top right picture shows that the fabrication work of the mirror itself used in the Kaguras. And also we have the many collaboration meeting and collaboration work in Japan. For example, the Kagura International Workshop. This is a Japanese meeting, but it was held in the Perugia University. And on the other hand, we organized some meetings for Einstein telescopes. The last fiscal years, we organized the Japan tours for the Einstein telescope, ISB, vacuum, and cryo teams. So first days, we visited the KEK, which is a national institute in Tsukuba cities. And after that, we moved to the Toyama, which is very close from the Kagura site. And next days, we went to the Kagura site, and finally, they returned to the Tokyo's. This is a picture of our collaboration meetings there. And also we, especially me, contributing to the Chaos project, which are promoting in the Perugia University now. So I'm one of the advisory board members. And also, from Japan, the Institute of Cosmic Ray Research, University of Tokyo, providing the opportunity to have the international collaboration research, inter-university research program. So by using these programs, every year, Italian people come to Japan and to do the collaboration researches here in Tokyo. And now we are contributing to some of the developmental researches in the Einstein telescope, very fundamental researches. For example, in comparison with the Kagura, we are currently working on the production of ultra-soft heat ring, which are used for the cryogenics part in Einstein telescope in futures. So this data shows that the developed heat rings in the Kaguras, and we are planning to apply this technology to future Einstein telescope too. So next, I wish to show that the present on-site work in Sardinia. So our young assistant professor, Tatsuki Washimi, just now working in Sardinia by joining the site work in Sardinian site for the Einstein telescope. So this picture shows that his collaboration work in Sardinia, and this is also another experiment, Archimedes experiment. This is ongoing in the Sardinian site now. He also contributing to this Archimedes experiment too. This is, yes, sometimes the Italian people come to the Japan to investigate about the underground environment to the Einstein telescope. So this is graph shows that such collaboration of the underground studies. And also he contributing to the analysis of the infrasound data of SOS Enatos, Einstein telescope site, operated by the Poland group too. So this is another pictures, Virgo member coming to the Kaguras. And finally, some of the people, Mark Barton and Lucia Torozzo, they were the faculty in our Japanese group in past, but now they are working in the Europe, and they are contributing to the Einstein telescope too. So anyways, we are keeping the very good collaboration between Italy and Japan. So we have to keep this collaboration even for future. That's all.
Thank you so much, Professor Tomaru. And I think that now we have a short video with your collaborator from SOS Enatos, so I kindly ask to the service to show it from SOS Enatos mine. I think is ready, almost ready. Okay.
This is Tatsuki Washimi from Japan, and now I'm mainly working on environmental noise of Kagra. And today I'm coming here. This is Sardinia Island, and that's mine. That is one candidate of the Einstein telescope, the next generation gravitational detector. And this is because here is a very small noise area. So I'm reflecting my experience in Kagra for this Einstein telescope site selection. Yeah, thank you. 私は国立天文台の鷲見と申します。はい、神楽で重力化検出器神楽で特に地下環境の雑音の評価の研究をしております。でその経験を生かして今回このイタリアサルティニア島のソソエンガトス鉱山に来ています。ここは次世代の重力波望遠鏡アインシュタインテレスコープの建設候補地の一つでして、そのサイトセレクション、サイトキャラクタライゼーションの活動に協力しております。
Hi, this is Domenico D'Urso. I'm the responsible of the characterization activity here in Sosonatos. It's a pleasure to collaborate with Tatsuki, also because we are benefiting of the great experience that the Japanese collaboration has already taken working a lot with the Kagra interferometer. So it's really a pleasure to collaborate with you, Tatsuki.
Yeah, thank you.
Okay. Okay, I want to, first of all, thank warmly all the speakers for your very nice and interesting presentation. But now I have some extra questions for you for a short discussion. I start with Michele. Michele, you mentioned in your presentation that there are 3 candidate sites for hosting Einstein Telescope. But how many instruments are really planned? We know that there are 2 options, and more in general, if you can share some insights on the state of art of the run.
Okay, yes. In effect, the original idea of Einstein Telescope was to implement a single triangular observatory, and so we need one site. But you know, in science and technology, we evolve. We made additional studies. And we saw that changing configuration and having exploding this triangular in 2L, we can, and this localizing this 2L in 2 sites that are far away, one from the other, we can improve the performance. And so the idea is, since Einstein Telescope is so appealing that everybody wants to realize, why not to realize it in 2 different sites, one in North Europe and one in South Europe, and then this is a possible configuration that we are studying. So finally, what is the status of the art? The status of the art is that we are working in this direction, and there will be a possibility to follow this possibility that will realize, will make at least 2 different countries happy. And it's a new possibility that we want to follow.
Thank you, Michele. And now I have a question for Professor Tomaru about the synergies between Kagra and Einstein telescopes. So, we know that Kagra is the only current observatory that is underground and with cryogenics technology. So also Einstein telescope will be underground with cryogenics. So the question is how this expertise of AGRA in these technologies can be useful for the development of Einstein telescope, and conversely also at the same time Einstein telescope can produce, can drive improvements also in Kagra.
Okay, thank you so much. Good questions. So first of all, after starting the Kagra project, I really noticed about the importance of the civil engineering.
Okay.
This is not a science, but needs many know-hows. So we, Kagra people, learned many such know-hows about the underground site civil engineering. So first, Einstein telescope must introduce our know-how to the future. In futures, of course, by keeping the good collaboration with Japan and Italy, it's not so hard work. And also, maybe from Italian side, maybe you also can learn about the many know-hows and also special parts of the underground site. So still now we are keeping the collaboration work of the underground site studies. In futures, maybe Newtonian noise is one of the key items. So to study about the Newtonian noise, now Kagura is one of the good places. So we can keep such kind of the collaboration work even in futures.
Okay, thank you so much. A question for Monique Bossi now. How important is the synergy between different actors in building a big and important research infrastructure, in particular in science? We saw that there are Sardinia region, the Ministry of University and Research, INFN, INAF, and other institutions. So it's important to create a synergy between these different actors. And so, also on the light of your experience in big research infrastructure, how is important this?
Yeah, thank you, Matteo, for your question. And indeed, as we saw, it is of paramount importance. It's fundamental. I would start my answer with a question. Why should 3 different countries, big countries, struggle to host the telescope? It's because, of course, there is a revenue which is both scientific but also economical and social benefits. So, of course, and because Einstein Telescope is such a big endeavor, of course you need a big commitment. And now we know that no one country can build it alone, and you need to collaborate. But of course, to be able to host such a huge infrastructure, you need to cooperate at national level, and you need to cooperate at regional level, because, as I said, we will build, hopefully, the telescope in Sardinia, and you need to be there to talk with the local people, to explain and to collaborate with them and with the authorities. Having such an infrastructure, but this is also, I think, well demonstrated by other big infrastructures hosted in different countries in Europe, has a huge impact, has a huge history of presence, and characterizes also the territory that will be hosting the infrastructure. So you cannot build it alone as a country, but you cannot build it alone as an institution. And of course, you need to cooperate at regional level, national level, but as we saw also at European level. And I think this is a very good demonstration of how it works, because we are here hosted at the Italian pavilion, hosted by the Sardinia region, and we had presentations from Ambassador Vattani, from Vice President Meloni, from Director Cardini, that shows again and embodied really the collaboration and the sound commitment that is, of course, needed, because otherwise no one is able. It's not a matter of Italy, Germany, or the Netherlands. It's really what is needed to do it.
Thank you, Monique. And now a question also for Alberto Masoni, because, okay, you talked about, Alberto, the many possible impacts of Einstein Telescope, in particular from the socio-economics point of view, but I'm curious about one very important impact, which is on environment. So we know that sustainability is a crucial theme in these times. So the question is how Einstein Telescope, a big project as Einstein Telescope, can address this effectively this point.
Yes, thank you for the question. It is true. The impact on the environment is becoming more and more a concern, and usually a large enterprise, a large infrastructure may give a significant economical development, but there could be a price to pay. What is, I think, the advantage of this proposal is that by definition, what makes, as was underlined several times, Sardinia and specifically the area of Sosenatos an ideal site are these environmentally characteristics. So we need to preserve, we need to keep these conditions. So by construction, Einstein Telescope will be that is being designed in such a way that with the principle that it is called do no significant harm, the NSH. That means that we will do this design in such a way to preserve the environment as it is.
Thank you, Alberto. And I thank again all the speakers of this first part of our event. So Michele Punturo, Monique Bossi, Takayuki Tomaru, and Alberto Mazzoni. And now we have a technical break, and I kindly call here on stage the speaker of the second part. So Andrea Contu, Federica Govoni, and Alessandro Cardini. Okay, in this second part of the panel, we want to go more deeply in Sardinia, so for understanding what is currently happening in Sardinia, starting from Einstein Telescope, and in particular for what concerns the activities already ongoing in the candidate site for ET. So we have the presentation of Andrea Contu, scientific responsible for ET in Sardinia. Please, Andrea.
Welcome, everyone. Today I have the difficult task to summarize the work of many people, which has been going on for years, and it will continue in the coming months and years, of course. And this topic is so vast that it will probably require days to discuss completely. I also needed help from these gentlemen to prepare the slides. So you already know where Sosenaton is, and let's start from the bottom of this slide. What we see in this site in that there is low seismic noise and low anthropogenic noise. So we can ask the question, what can we do in this site? We can do a lot of science, a lot of the science that requires these silent sites. We can have underground experiments. We also have already the mine in Sosenatos, in which we hope that ET at some point will come, but we already have many activities going on that go also beyond Einstein Telescope. We have a seed of ET, which is the Shallgrave laboratory, that will evolve in a more, let's say, larger structure, as you will see in the coming slides. The first thing we have to do is to do geological studies, because we have to prove that Sardinia is stable, that is stable enough that can host a large infrastructure such as the Einstein Telescope. And of course, we did that. I'm not going through the details, as you can imagine, because there will be a lot to talk about. But we studied the type of rocks that we find in that is mostly granite. So it's very solid rock. Sardinia is seismically very stable. Much more stable than what you see in the rest of Italy, for example, or it's one of the more stable sites in the world. But what we also need to do to prove that our site is the best is to do some monitoring. So monitor several types of noises. Since 2019, we have many sensors installed in the Sosenato mine. Keep in mind that the mine will not host Einstein Telescope itself because it will be a large infrastructure. So when I say Sosenatos, I mean the Sosenatos area. But of course, the mine was very important because it allowed us to go easily underground and install our instruments. Most of these instruments are seismometers, which have a very obvious purpose, but we also have a weather station because we have to correlate the noise with the weather. We have barometers to measure the pressure very precisely. We have magnetometers because magnetic interference can become vibration in some way, so it's a danger for gravitational wave detectors. And we also have microphone and also other experiments. We have several stations in the mine, as you see there, at different depth and at slightly different locations. But also, as this is an extended site, we have to dig boreholes. You see here the triangle shape we envisaged to host the Einstein Telescope, and we had to dig boreholes and also instrument those. and install seismometers both on the surface and at depth, along with magnetometers. We have several measurement campaigns. We have an acoustic measurement campaign completed in one of the sites away from the Sosenatos mine, which we call P2. We perform gravimetric measurement to measure how the gravitational force from the Earth varies in the site. And in the next months, there will happen something very important, which we will have a very high-speed connection. This is coming from the Terabit project that was mentioned by my predecessors. And we will have a very fast connection. And of course, we are also instrumenting more stations in other vertices, because at the same time, we are investigating the triangular shape, but also the L shape. So we are also performing other measurements. One type of noise we hunt is, for example, those given by the wind turbine. We recently produced a work on we installed seismometers at different distances from a very large wind park, one of the largest wind parks in Italy, and we installed 9 detectors. You see on the left the one which is closest to the turbine, and the one in the middle is the one which is closest to the foreseen interferometer. So you can see that the noise decreases, but we can still see something. And this is a very important study also to plan not just the area of the Einstein telescope, but also to monitor what happens around and be prepared for that. Now let's come to a more quantitative estimate. This is all documented technically in the paper I quote here. But what I'm showing here, this is essentially the seismic noise we measure in the 2 sites. In the blue one is the seismic noise in P2, so one of the boreholes we excavated in Sardinia, and the orange one is Tertiair, which is our competitors. This is in the EMR site in the Netherlands. In this kind of plots, what you would like to see is that the lower you go, the better it is. It means that the noise is low. And you can see here that the noise in Sardinia is roughly a factor between 5 and 10 lower across all the frequencies of the gravitational waves with respect to our competitors. And actually, if you are scientists, you can also see that we are also on the high frequency on the right. We are very close to the self-noise of the instrument. So that tells you that we actually need a better instrument, a more sensitive instrument to perform really precise measurement, and that probably the site is even more silent than what we measure. But we want to translate this seismic measurement also in the impact of the Einstein telescope physics. So we perform an estimate, and again, the 2 bands are the 2 sites, so blue is Sardinian, orange is the Netherlands, and you can see that in the low frequencies, which is one of the most interesting for the physics of Einstein telescope, because will allow us to see new sources of interesting sources of gravitational waves. Again, our site is very close actually to the ideal case, what we would like to have for Einstein telescope, and in some cases is even slightly better than what we need. So this is very good, and it proves how good is the site we have. I'm not going on the technicalities here, but for the sciences, the number I show here show you how would you see the gravitational wave events we have already observed in the past with the current gravitational wave detectors, and we will see them in the Sardinian site and in EMR site. And you can see again that the message is that, again, the Sardinian site would have a higher signal over noise ratio. But also we investigated the impact of more, let's say, other sources of gravitational waves, for example, intermediate mass black holes, which are one of the main goals of Einstein telescope, or binary neutron stars. So so far we talked about black holes. Black holes do not emit light, so you can only observe them using gravitational waves. While if you have other compact objects, such as neutron star, for example, when they collide, they do emit gravitational waves, but they also do emit light. So you can observe them in both ways, and this is very This is very interesting, and again, we can do this better in the Sardinian side with respect to the EMR side, without of course applying any active noise mitigation, just with using what we have from Mother Nature. Another aspect which is very important is of course engineering, and that's why there is a company at the moment that is digging boreholes along the path of the triangle configuration and the L configuration that we think are the best in Sardinia. And actually the drilling campaign started in July 24 and is now completed. We did it, essentially what we do is we extract the rock at depth between 200, 300, 400 meters, and what you get usually is this. It's basically granite everywhere. Also, there are a lot of collateral activities. Of course, our goal is to bring Einstein telescope, but since you have this silent site, you can do a lot of other stuff. For example, what is now SARGravity will become SunLab. There are already funds for that, and construction will start in a couple of months. Now we work in this hangar, which is not very nice, but we plan to build a proper lab to host several initiatives, not just from INFN, but also from INGV and INAF. And also we attracted the interest of another type of science, which is geology and geophysics. The National Institute for Geophysics, for example, was not in Sardinia, but it came in Sardinia thanks to Einstein telescope. They help us with their skills to characterize the sites, but they also have their own plans, because in Sardinia you cannot only look at the sky, but it's so silent that you can also look underground and monitor the entire Earth. For example, in the map I show you here, which is Sardinian-centric, the red dots represent on the right part. They represent all the seismic events that you can see around the world. So that's good science on its own. It's not fundamental physics, but it's also good to show that all the potential of this site. Again, talking about INGV, they have several seismometers all over Sardinia. That, of course, will improve our understanding of what happens around the site, even very far from it. Let me come to the conclusions. So the characterization team is working hard, as you saw from the slide from Professor Tomaro. They are working. I should be there actually, but I had the privilege to be here and enjoy Japan. The data, I think, strongly shows that the Sardinian site is ideal for Einstein telescope. It's actually one of the best in the world. We can host both triangular and L shapes, and their positioning is already assessed. We have their position where we would like to put them. And another important thing is that the goodness of Sardinia goes beyond Einstein telescope and already attracts partners and research institutes. And SunLab is a very example of it. So it's functional, but again, independent of Einstein telescope. Thank you.
Thank you, Andrea. Thank you so much. And now we meet again Alessandro Cardini, director of the INFN Cagliari section, but in this case with the hat of representative of the ARIA project.
So good afternoon again. So I will present this project, which is not a fundamental science project, but it's for the fundamental science. So let me start off where we started. So as you know, the planets, due to the Kepler law, they are, let's say, they are faster, the one which are closer to the sun. Okay, so we know how things work in the solar system. But when we look at the galaxy, we expect something similar, but this is not what we get. So this is why we could explain the anomalous rotation of the galaxy as with the existence of an extra mass, which we don't see because it's not bright. There are no stars, but it exists because gravitationally it has an effect. And we call this unknown matter the dark matter. And the dark matter could be of many origin. And one of the possible type of dark matter that some experiments are looking at are the so-called WIMPs, weakly interactive massive particles, which are very difficult to detect because they don't emit light, they do not interact with ordinary matter, they are not charged. So we want to see if we can detect those particles. The idea is to build a huge, let's say, container with argon inside, and if there is this black dot, which is the dark matter, hitting an atom of argon, it will emit some light, and the light also, and some electron also, due to the ionization of the atom, will also produce some extra light. So such an experiment will be sitting there in the Gran Sasso National Lab in the center of Italy, under a mountain, in one of the big halls of the laboratory of Gran Sasso halls. This is what has been built up to now, the test prototype, and this is the construction of the current experiment, which is called DarkSide, that will contain 120 tons of argon, 50 of which are the detector part. And this is the shape of the detector, and in particular the central part will contain the argon, and the outer part, there in yellow around the central core, contains the so-called veto, the part that is needed to be sure that what we observe inside is not something coming from the outside, from the cavern. Not only this type of experiment will make use of this type of argon, but also this other experiment called LEGEND. The idea of this, the purpose of this experiment is to understand the nature of the neutrino. Why we want argon, and what is the problem with argon? The problem with argon is that we have, most of the argon is made of argon-40 on the left, but there is a tiny part of argon, naturally, which is argon-39, which is a radioactive isotope. And the problem is that if you fill a pool with argon, the argon-39 will mimic a possible interaction of dark matter into the detector. So we want to use only argon-40 for such an experiment. So how do we do it? The idea is to try to find a source of argon-40 only, what we call a depleted argon, and we found a place here in Colorado. There is a company extracting CO2 from underground, used in the oil business, but part of the gas which is extracted also contains argon, and this argon is mostly argon-40. So we are building near this Kinder Morgan place, which extracted the CO2, an area that will have to, let's say, extract the argon from this gas. And this is the so-called Polaris Tower that will act as a distillation plant to extract this argon. This is in construction. This is April 2025, so very recent. Those are the containers that will need to export the argon to Europe, and this argon will come to Sardinia. Why it will come to Sardinia? Where you can see ancient historical sites on your right and most recent site on the left, all together in the same picture, because this part here represent old let's say mines that are not anymore in activity, but there is let's say the infrastructure which is there, and in particularly we will use the pit of one of these coal mine at 400-meter deep pit to install a distillation column 350 meter long. And with this distillation column, we will clean again to the amount of cleanliness that we want this argon which is coming from the United States. So these are the components of the distillation column, which is a standard distillation column, but cryogenic in this case. I do not enter in all the technical details, but we are all the modules ready for installation. This is the top of the tower that will, above the pit, that will be used to bring down all the components. This is the whole of the pit where the pre-installation of the system is ongoing. Another picture of this complex operation in this 350-meter deep hole. There is a lowering test that we did in order to assess what is the best way to install such a complicated column. And here are some tests which was done a couple of years ago, entering the modules and extracting them again. This is a picture of the modules going down. And for the time being, a small, only one module is used for a test column that is already installed there in this place in Sardinia. And you can see here the infrastructure, which has already been tested and demonstrated to perform as expected. So this is a short version, but it's almost 30 meter high. So it's a very interesting system. This is the demonstration, technical demonstration that everything is working. And so this is the story. So we have in Sardinia also a technological research activity that will and the output of this activity will be used by current and future experiments that are requiring very special tools for their science. Thank you.
Thank you, Alessandro Cardini. And now we have a very special contribution, a registered contribution from the Nobel Physics laureate Arthur McDonald, that won the prize in 2015 for the discovery of the neutrino oscillations, a pivotal mechanism in the field of particle physics that is strongly, the Nobel, I remind, also shared with Japanese scientist Takaaki Kajita, and McDonald is strongly involved in the ARIA project. So we have a contribution. I kindly ask to the service to show it, please.
Hi, I'm Art McDonald. I'm the Gray Chair in Astroparticle Physics Emeritus at Queen's University, Kingston, Canada. I received the 2015 Nobel Prize in Physics along with Takaaki Kajita for the discovery of neutrino oscillations, giving us new properties of neutrinos outside the standard model of physics. We are now pursuing the study of dark matter in an underground laboratory in Italy, the Gran Sasso Laboratory, 3 hours east of Rome, and also working on a part of the project essential for our success, which is taking place in Sardinia, to purify the argon that we use in the central part of our detector. This is to study dark matter, which we know exists in our galaxy, but which we have no idea its composition. It's not like the ordinary matter from which we are composed, but it's very important in terms of the evolution of the universe since the Big Bang. Current theory, which is very strongly supported by a variety of evidence, indicates that the current universe was created about 13.6 billion years ago in an enormous explosion during which the fundamental particles, quarks, electrons, and neutrinos were produced and then coalesced into neutrons and protons in the case of quarks, into hydrogen and helium nuclei after about 3 minutes, neutral atoms after about 300,000 years, and then after about 1 billion years, they began coalescing into galaxies and stars and planets and us. Now, the formation of that structure requires dark matter, which has been identified elsewhere, total mass about 5 times as much as the ordinary matter from which we are composed. There's strong evidence from galaxies like our own, which are shaped like a spiral, as you can see on the right. If you measure the velocity of stars as a function of distance from the center, you find that the outer stars are going so fast that they would fly off into space if they were not held in place by much more than the amount of mass known to exist in the glowing stars. You don't see this when you look at the Milky Way galaxy, and that's because you're looking at the edge of it and looking through it and see it as a pattern of stars across the sky. One candidate for this dark matter is so-called weakly interacting massive particles, which as we move through our galaxy and as we go around the sun with our experiments here on Earth, we could have situations where these WIMPs, as we call them, hit atoms in our detector and causing them to recoil just like a billiard ball. The experiment I'm going to describe uses 100 tons of liquid argon, also obtained from an underground source, to look for signals that come from the recoil of atoms after being hit by a dark matter particle. The reason it's valuable to use liquid argon is that if we see an event that comes from the recoil of a nucleus, it occurs in about 10 times 10 to the minus 9 seconds, 10 nanoseconds, in other words, whereas other radioactivity takes much longer, up to 500 times longer, and so we can discriminate against that other radioactive background. The experiment is in the process of being built at the Gran Sasso Underground Laboratory in Italy, about 3 hours east of Rome. But in order to do the experiment, we require low radioactivity argon, which we have identified as existing in a high pressure carbon dioxide stream in Cortez, Colorado. We have built an extraction facility there, and we are in the process of building a final chemical purification column, size of the Eiffel Tower in Carbosulcius, Sardinia. With this, we are able to extract the argon from underground, transport it, as you can see with the arrows on the map, to Sardinia, and then after purification, transport it to the laboratory, Gran Sasso. We've done a number of tests already with the first unit of the purification column, which behaved very much according to specifications. And we are now in the process of completing the installation of about 20 of these modules in a previously abandoned coal mine in Carbosulcius. And when we are finished with our work, the final distillation column will be used for the commercial production of non-radioactive medical isotopes, such as oxygen-17, oxygen-18, and carbon-13. We've improved the head frame and now are in the process of installation of the remaining modules to produce the full column. Throughout this project, we've had excellent cooperation and support from the government of Sardinia, and that has made it possible. We also have strong support from the Italian funding agency, INFN, for the whole project, both at the area facility in Sardinia and across the full project, including the work being done at the Gran Sasso Laboratory. And so based on our experience, I can strongly recommend Sardinia and Italy as places to do basic science at the frontiers of knowledge. Thank you very much.
Okay, we thank remotely Art McDonald also for this last message that I think is very clear also in the context of the Italian candidacy for Einstein Telescope. And so, last but not least, Federica Govoni, Director of the Astronomical Observatory of Cagliari of National Institute for Astrophysics, will talk about Sardinia Radio Telescope.
Okay, good afternoon. It's a pleasure to be here in Osaka and to introduce the Sardinia Radio Telescope. That is a research infrastructure that observes the universe at radio wavelength. Well, so SRT is one of the most innovative and high-performance radio telescope in Europe, and this thanks to its large collecting area. We are talking about an antenna with 74 meters of diameter. It's very important for its frequency agility, so SRT can work between 300 megahertz up to 100 gigahertz, and the astronomer can switch very quickly the observing frequency, and this is the frequency agility, and they can save a lot of time to observations. And finally, it has a active surface, which means that the main mirror is made by panels, about a mosaic of over 1,000 of panels that can be slightly moved, and in this way we can correct for deformation due to gravity, temperature changes, or wind. Okay, so SRT is located in San Basilio, north of Cagliari, and it is managed by the INAF Institute. And it can work as a single dish antenna, but also together in a net of telescopes through the very long baseline interferometry technique. With this technique, it is possible to obtain very high resolution radio images. So SRT can work together with the other Italian radio antenna located in Medicina, in Noto, within the European VLBI network. And very recently, INAF also signed a memorandum of understanding together with the research observatory in South Korea and with the National Astronomical Observatory here in Japan. And it is very important to use this antenna altogether for very long baseline interferometry. Okay, so we love radio astronomy also because it is possible to observe the sky with radio astronomy also during the day, and sometimes we also observe with, depending on the frequency, also with cloudy. But it is important for astronomers to stress that it is absolutely important to observe the universe over the entire electromagnetic spectrum, starting from gamma ray, passing through X-ray, infrared, visible obviously, microwave, and radio. And to show you how it's important to observe the universe at different wavelengths, I show you here a famous galaxy. This is M51. Here you have the optical emission, and in the other side you have the radio emission. And here the light is due to the light coming from all the stars of the galaxy. In one galaxy like this, which is quite similar to our galaxy, we have something like 100 billion of stars. And if we compare the optical and the radio, we see some difference, but it is not so different. The radio is much more smooth, but the difference is not so big. But give a look what's happening if we observe an elliptical galaxy. Still, in the optical, we have the emission which comes from the light of the stars, while in the radio, we have a completely different morphology. We have a core, 2 jets, and 2 lobes. And if we compare them, they are completely different. In the radio, the emission can be explained only if at the center of the galaxy, we have a supermassive black holes. So this is an example to show you how it is important to observe over the entire electromagnetic spectrum to understand better the physics of the object of the sky. Okay, so this is the timeline of the SRT. We started the science activity in 2016, and after that we have 2 stops of the science activity. The first one to upgrade the active surface of SRT, and the second one, and also to move all the instrumentation to new buildings. Here we have the new buildings with a nice control room. If the astronomer observe the sky for a lot of time, they can stay in our guest house, and you have a team of project friends which help the astronomer to do the observations. But we had also another stop, this is a very good stop, due to a POM project financed by the ministry, in which we obtained 20 million euros to upgrade SRT to study at high radio frequencies. And okay, so with SRT we can do a lot of science with in VLBI and also with single dish. Here are indicated some of the science that we can do, but I would like to concentrate on the gravitational wave detection and on the electromagnetic counterpart of gravitational waves. During the event of binary neutron star merger in 2017, SRT observed the sky for follow-up observation in the radio. So we are ready to operate in synergy with LIGO and Virgo, of course, but in the future also with Einstein Telescope. In addition, SRT can also work in a complementary way with Einstein Telescope, because SRT is part of the European Pulsar Timing Array, which is made by the most large radio telescope in Europe. And with this technique, we try to detect a gravitational wave, a signal of a gravitational wave, which is a background probably, which comes from the merger of supermassive black holes. And to do this investigation, the European Pulsar Timing Array observe a sample of pulsars to check if the signal of the pulsar is modified by the gravitational wave. And so to do all this science with SRT, it is really important to have a large number of receivers which work at different frequencies. In this way, we can study in a wider way the universe. And since 2019, we had 4 receivers which were located in different focal position in SRT. And the highest frequency receiver is the K-band receiver, which is located in the Gregorian position. And there we have a turret, and the astronomer can move this turret to change very quickly the frequency of the observation. And after the upgrade due to the POM project, we were able to equip SRT with 4 new receivers, and now we can really observe up to 100 GHz. And this is the situation today at the Gregorian focus, so with a new set of receivers that can do new science. And very recently we published a press release to show a few new images at 90 GHz with SRT. Here we have a supernova remnant, Cat-A. There we have M87, which is a supermassive black hole at the center of a galaxy. And this is the Orion Nebula, which is a star-forming region, and we imaged the central part of the Orion Nebula. And I thank you by showing you a picture of the SRT while it was observing Orion Nebula. Thank you very much.
Thank you, Federica Govoni. Okay, I have a short question for, firstly for Andrea and Federica about the possible connections between these 2 big research infrastructure, Einstein Telescope and Sardinia Radio Telescope. Of course, in the hypothesis that Einstein Telescope will come in Sardinia, both from the point of view of the gravitational physics, so Einstein Telescope, and the astronomy with SRT. Andrea.
So there is a strong connection in terms of multi-messenger physics. So observing the same event in 2 ways, via gravitational waves and via optical or radio waves. These events are usually black holes colliding. So they rotate and they emit gravitational waves, and they at some point they collide and emit a burst of gravitational waves which can be usually detected by detectors, but they do not emit light, so we cannot observe them in any other way. While there are, for example, neutron stars that emit light, so they rotate, they get closer and closer, and they emit stronger and stronger gravitational waves. At some point they collide, they emit a burst of gravitational waves, but also they emit a flash of light. Let me call it like this. And the crucial thing is that the gravitational signal grows with time. So you have to be able to observe very far in the past, at least days, for example, or months, to be able to tell to our colleagues that do astrophysics, look, in 2 days or 1 week, there will be a collision between two neutron stars. Be sure that you have your radio telescope pointing there so that we can see the interesting part. We can do good physics with it. For example, with this kind of events, we can study the nature of matter in extreme conditions, such as the neutron stars. But I will let Federica comment on that.
Yes,
Please.
I agree. Doesn't work.
Is working? Okay.
I agree that the synergy between, for example, SRT and Einstein telescope is related to multi-messenger astronomy. We were present in 2017 with SRT to follow up in the radio the event of a merger of binary neutron stars. Yes. However, I have to say that to be ready for the future, for the Einstein telescope, we have to improve again SRT. For example, with this upgrade of the receiver, we did a very important step. But for example, we need also in the future to organize a dynamic scheduling of the SRT observation to be ready in the moment in which the event occurs. And also we need to remotize the telescope and to have more operators. So we have to work much more in a similar way like the VLBI, so with the service mode. And in this way we will be ready and the synergy will be completed.
Thank you. And I have a similar question for Alessandro Cardini about ARIA. Which connections with other projects, for example, national, international, there are, and also new synergies that might emerge also in the future?
Yeah, thank you, Matteo, for this question. In fact, ARIA started as, let's say, a technological facility to produce something, but something that was required by fundamental physics. The search for dark matter has been started a long time ago and is pursuing, and we hope to see some signal. And the use of argon in the underground detectors, like in Gran Sasso laboratory, it's one way to go. And the fact that the argon is partially, some isotope of the argon is radioactive, requires some special technologies. And this is why, let's say, the ARIA project has been thought and has been realized, and it's being realized and down in the Carbosulcis mine in Sardinia. So, let's say, ARIA is at the service of fundamental physics. This is how it started. But this is not the only purpose of a technology, of the ARIA technology. In fact, in the world, there is an increasing request of specific isotope, for example, of carbon, oxygen, and so on, that are used, for example, in medical application. And ARIA, which with its specific distillation capabilities, can be a way to produce in a cheaper way with respect to the way that we are now producing isotopes. So they can produce isotope, and this is one way to go. Mm-hmm. So ARIA, it's somehow, let's say, a bridge, a technological bridge between fundamental physics and the today our life, the social, let's say, social life, and so it has really a wide spread of possibilities.
Thank you. And now I conclude with a final question for all of you about a very important point. In these large experiments, large infrastructure, it's very important to build a strong and a nice relationship with the local communities involved. It's important to have a full acceptability of the project in the territory. And how are you addressing this crucial point? I would like to start with Federica, also because SRT is operative since more than 10 years, so I think it's a useful experience also for example, for ET.
Yes, I completely agree. It's really important that the relationship and the respect between the research infrastructure and the territory. I think to obtain the best results is to organize the event together with the territory, like in this case, because it is important, because we, as astronomers, we can understand better the territory, and at the same time, the territory, if knows the infrastructure and what we are doing, can understand what they can do to grow together with the infrastructure. So this synergy is absolutely fundamental.
Okay, Andrea, I know that already in today there is a very important relationship, for example, in Zosenatos between scientists and the miners.
Yes, it's true. I mean, this is one of the many skills you have to acquire to build a gravitational wave detector. Not only geology and engineering, but you also have to have social skills, because the people living there has to know what's happening, what will come, and what the opportunities are. And we start from the miners, of course. They've been extremely useful. They are still extremely useful to help us installing all our measurement system. They've kept the mine in a mean condition. I mean, you probably will never see a better mine than this. It's very clean for what a mine can be clean, but it's perfect. They are, to me, they are part of the project. And we even have football matches among us. They win always, because they're much better than scientists, but that's important. But beyond that, we also we go to schools, we have many social events. It's important that people is informed.
And Alessandro Cardini, the same question about the territory around the ARIA project.
Yes, ARIA has been and it's being an important for the future of the region. This part of the region on the southwest of Sardinia, the Sulcis, has a very long-standing tradition in coal mines. So there are a lot of people which have always worked in mines. And the fact that we bring, let's say, something there and that can represent a future, let's say, not for the mine, not for the coal, because there will be no more digging of coal, but it will be a future for the miners that will not change their job, because they will continue to work on a mine, maintaining an infrastructure that will be sitting there and not digging the coal. But so this represents really a future for the place, for the Sulcis. So I think this is extremely important, because it will allow the region to continue to maintain the skills they have been, let's say, developing since hundreds of years in a new way, for a new purpose, and a very interesting purpose for the society.
Thank you, Alessandro. I don't know if there are any questions also from the audience. If not, I think that we can conclude this session. I warmly thank again Andrea Conto, Alessandro Cardini, and Federica Govoni, and also the speakers of the first part of the event, and thank you for your participation. Thanks again.